See, in this question 10 ampere is divided into two parts. Okay, let us suppose this one as I1, so this one would be 10 minus I1. Then in suppose again current is divided, so we can consider a I2 current is flowing. So how much is the current flowing? Incoming current is positive and outgoing current is negative. Okay, so again we have to consider this current also, that is I1 is incoming and I2 is also incoming. In the last we'll see whether answer would be 10 ampere or not. Both are incoming, I1 and I2 would be cancelled out and answer would be 10 ampere, means our direction marked is correct. Okay, so in this we have done current mark in according to the branch current method, because we have marked the current in branch. So that would be, again we have to mark the sign, right, like this. So we have to apply KVL in mesh 1. Apply KVL in mesh 1. How much it is? Minus 2 into plus 5 into I1 is equal to 0. For mesh 2, minus 2.4 I2 plus 4.5 I1 plus I2 plus 3 I2 is equal to 0. Now we are having only two variable I1 and I2. We can solve it and then we'll get the value of I1 and I2. But see what they are asking. They are asking the potential drop across 3 ohm. Okay, so in this 3 ohm, how much is the current flowing? That is I2. So I2 multiplied by 3. Whatever the value you will get, put it in this equation, then you will get the voltage across 3 ohm, right? As according to Ohm's law, V is equal to I multiplied by R. Again, if we need to calculate the voltage across 4.5, that is I multiplied by R. In 4.5, how much current is flowing? That is I1 plus I2. So after solving this equation, we'll get the value of I1 and I2 as well. And R is how much? 4.5. We can substitute it, then we'll get the voltage across 4.5 ohm. Clear?